All right. So what we are going to look at today is we're going to use our quadratics to solve life-like situations. All right. So first thing I want you to do is I need you to get out your Chromebooks and I need you to go to desmos.com. So I'm gonna go ahead and share my screen with you and we can see our desmos.com right here and we have this calculator. What we're going to use this for is we're actually going to graph our quadratics and we're going to use them to find solutions for our problems. Okay, so you can hit pause right here, wait till everybody's ready with their Chromebooks. I'll just hang out for a second. I don't know if you hit paused or not. So, all right, hit play if you're ready. If not, here we go. So what we're going to look at is this problem here. Okay, so I'm going to read it here. It says, a firework rocket is launched from a hill above a lake. The rocket will fall into the lake after exploding at its maximum height. The rocket's height above the surface of the lake is given by g of x. What is the maximum height of the rocket? So if you remember when we talked about graphing quadratics, we talked about how the vertex can be a maximum or a minimum. In this case, we're looking for the maximum of our quadratic, so it's going to be an upside down U, upside down parabola. So we have our equation here, our negative 16x squared plus 64x plus 80, and we're going to go ahead and we're going to type that into our Desmos calculator here. So I've kind of got to make my screen a little bit smaller so we can see both the equation and my Desmos at the same time. So, okay, here we are. So my equation, I'm typing that in here, is negative 16x squared plus 64x plus 80. Okay, and I'm looking at my quadratic here. I don't really see a quadratic, but if I zoom out, there's my maximum, clear up there, we see that? So I'm gonna come in and I'm gonna zoom in on that maximum there, and I'm gonna click on it. When I click on it, it's telling me the point 2 and 144. 2 is my x value, which is time. After 2 seconds, I'm gonna hit my maximum height. The y value is 144, which is my maximum height. So after 2 seconds, I hit my maximum height of 144. Pretty simple, right? Okay, so a follow-up question for this very same quadratic, if we take a look here, this second question asks, same situation, firework rocket launched above a lake, but now it's asking the question, how long will it take the rocket to hit the lake? So remember, it's launched from a hill, it's going to hit that maximum height, then it's going to come down and it's going to hit the lake at some point. Since our function tells us the height above the surface lake, when our function equals 0, that's when we're going to be hitting the lake's surface. So we're going to go back down here to the x-axis. If I were to zoom in on the x-axis, right here is when it equals 0 at 5 seconds. So after 5 seconds, that rocket is going to hit the surface of the lake. So we can use our quadratic to interpret that information. Remember, our x-intercepts are our solutions. That's what we're looking for. Okay. So we'll look at one more and then I'll leave the rest for you guys to practice. So this question says a rock is thrown from the top of a tall building. The distance in feet between the rock and the ground x seconds after it is thrown is given by f of x. How long after the rock is thrown is it 340 feet from the ground? Okay, so that's asking something else. That's asking about a specific height, which is 340. So for starters, I got to plug that function back into Desmos. So Sorry, I've got to make my screens fit here again. So I'm going to come over here to Desmos, get rid of that quadratic, and I am going to type in this new function right there. Okay. Oh, my Desmos is still too large. Sorry about this, guys. Good old technology. Okay, so I'm typing in again my function into Desmos, -16x squared minus 4x plus 382. All right, I'm going to zoom out again so I can kind of get that generic look at my quadratic. Wow, this one's a tall one. All right, so if we look here, we're starting out on top of a building at 382 feet, right there. We toss a rock. I want to know when that rock is, whee. I think it was 340 feet, right? Yep, right there. 340 feet from the ground. So if we come back to our Desmos here, if you click on a point on our quadratic, see how it's telling me my x and y values? And as I move that point changes. I need to know when my height is 340. Height is given by y. So I'm going to scroll here until my y value tells me 340. So I'm going to start down here around 340. That seems like a good idea, right? Okay. So I'm going to click here, and then let's watch that point until that y value is 340. Boom. Oh, at 1.5 seconds. So at 1.5 seconds, my rock is 340 feet from the ground. All right, so I'm going to post a couple more problems for you guys to give this a try. The practice test is up for solving quadratics, so you could try the practice test as well. And if you guys got questions, let me know. Okay, I'm going to stop sharing my screen now, and I'm going to stop recording.